Hi guys, today's topic is Mycobacterium tuberculosis. Coming to the general properties of this Mycobacterium tuberculosis, they are acid fast. That means they resist decolorization by acid. This acid fast staining is also known as Ziehl-Neelsen staining. Hope you might have studied it earlier, like this acid fast staining. And this property is very important property of this. This is a very important property of this organism. Okay, then the next point it is their nucleic acid content. The 60 to 70% of their nucleic acid content comprises guanine and cytosine. They are non-motile organism and non-sporing, and they are gram-positive rods. They are they give weak staining on this gram staining because their cell wall is less permeable to gram stain. So they are weakly gram-positive. They are rod-shaped bacteria, and their peculiar feature is that they have a unique structure of their cell wall. It is like from below to up the cell membrane, and just outside the cell membrane they have a peptidoglycan layer which gives as you all know, the rigidity and shape to the cell wall. The cell membrane is having bilipid layer structure, and above this cell membrane they have peptidoglycan which gives rigidity and shape to the cell wall, and above that the peptidoglycan they have a peculiar feature which is arabinogalactan. This arabinogalactan helps to survive inside macrophages. That we will come into that later. I'll explain it later. And then here comes the another important segment, that is mycolic acid. These two things are very important contents of their cell wall: mycolic acid and arabinogalactan. As this mycolic acid is thick and making the cell wall less permeable. As I said earlier, the cell wall is less permeable to gram stain, and the reason for that is the presence of mycolic acid on their cell wall. And on the top of that they have mycocytes, they are glycolipids. Then coming to the next, the pathogenesis. The bacteria, they are transmitted through respiratory aerosols. In case of pulmonary TB, as you all know, Mycobacterium tuberculosis cause the tuberculosis, and tuberculosis are of mainly two types: pulmonary TB tuberculosis and extrapulmonary TB. In case of pulmonary TB, it is transmitted through respiratory aerosol and the consumption of unpasteurized contaminated milk. But this mode of transmission is rare, as we are in most of the countries they are using pasteurized milk. So the infection by consuming this is very rare. The main transmission agents, they are respiratory aerosols. The inhalation of this respiratory aerosol, after the inhalation of this respiratory aerosol, it reaches the upper respiratory tract. Upper respiratory tract, they contain ciliary lining which helps to get rid of this bacteria. Like in our nose linings and all, we have these hairs and the ciliary lining, and it helps to get rid of this bacteria. So only 5 to 10% of the bacteria which reaches the upper respiratory, out of the total bacteria which reaches the upper respiratory tract, only 5 to 10% of bacteria will reach the alveoli, that is alveoli in our lungs. Then the macrophages, they are present in the alveoli and they detect the bacteria with the help of complement receptors. Then when this macrophages detects this bacteria, phagocytosis occurs. The macrophages engulfs this bacteria, but the arabinogalactan present on their cell wall, it impairs the phagosome-lysosome fusion. That means during phagocytosis, we might have studied that phagocytosis is just like amoeba engulfing its food, and the macrophage eats this bacterial foreign particle and it forms a phagosome. But inside the cell, this phagosome, the phagosome combines with the lysosome. Lysosome have a lot of protease enzyme which act on this foreign particle to dissolve or digest that. There is this phagosome-lysosome fusion will be there. But this arabinogalactan present on this bacteria's cell wall, it impairs this phagosome-lysosome fusion. And so the macrophages fails to kill the bacteria. And the bacteria replicates, so it fails to kill the bacteria, and the bacteria will be residing inside the macrophages. The bacteria replicates inside these macrophages, and at the same time macrophages activates T helper cells. Macrophages activates T helper cells. T helper cells, they are of two types, Th1 and Th2. Mainly here the Th1 is explained here, and the Th1 gives two types of response, that is macrophage activating response and tissue damaging response. In normal cases, the macrophage activating response will be higher than the tissue damaging response. The macrophage activating response will be higher and tissue damaging response should be lower in the norm. That is the normal case. And now coming to this macrophage activating response, if the Th1 is functioning properly, the macrophage activating response will be activated, and then there forms the tubercles. Tubercles will be formed. There are two types of tubercles, hard and soft. First of all, hard tubercles will be forming, and these hard tubercles later convert into soft tubercles. So that means these tubercles are macrophages itself. Macrophages having this bacteria inside. So it become hard as this bacteria multiply within this macrophages. And when the cells die, because this bacteria they will not get oxygen anymore as they multiply uncontrollably, so many of them die. This bacteria dies, and so this is the sign of a good immunity, and the infection will be under control. If the T helper cells is means functioning properly, the macrophage activating response will be activated, and there forms the tubercles. And when these tubercles, inside these tubercles, the bacteria get multiplied, but they will be soon deprived of oxygen and they dies. This is a good sign of good immunity, and the infection will be under control. But in some cases, the tissue damaging response will be high, and that will be in case of immunocompromised. Macrophages are not so effective, so the tissue damaging response will be higher there. So there will be no tubercle formation. Then excess proliferation of bacteria will be there. then the lungs will be damaged, and after this lungs damage, they may spread to various part of the body, leading to the disseminated TB. Disseminated TB means tuberculosis in all parts of her body. Clear? So these macrophages, first we told that after inhaling this aerosols, they will reach our alveoli. Then in alveoli, macrophages will be activated, the phagocytosis will be occurring, but the arabinogalactone layer, it impairs phagosome-lysosome fusion, so the macrophages fails to kill the bacteria, and the bacteria replicates inside the macrophages. Then the macrophages activates T helper cells, and they have two types of response. In good immune, if the people are healthy, the macrophage activating response will be there, and it will lead to the death of this bacteria. The infection will be under control. But in case of immunocompromised people, macrophages are not effective, so there will be no tubercle formation. The excess proliferation of bacteria will be there. It will eventually leads to lung damage and the spread of the infection to the various parts of the body, and it lead to disseminated TB. Coming to the clinical manifestation of this tuberculosis, Mycobacterium tuberculosis. The tuberculosis are of two types: extrapulmonary TB tuberculosis and pulmonary TB. The pulmonary TB is again classified into primary pulmonary TB and secondary pulmonary TB. Now we will look at the primary pulmonary TB. It occurs when a person comes in contact with Mycobacterium tuberculosis for the first time. When a person comes in contact with Mycobacterium tuberculosis for the first time, he will confer primary pulmonary TB, and it has three phases. First one is it can resolve spontaneously. In majority of the cases, it will resolve spontaneously. And in some other cases, latent TB will be there. It means there will be no clinical manifestation, but may get reactivated later. The bacteria may get reactivated later and may develop into a pulmonary TB. Then third one, it is primary progressive TB. Active infection of this tuberculosis occurs in this primary progressive TB. Coming to the clinical manifestations, the organs affecting it is the upper part of the lower lobe and lower part of the upper lobe of lungs are involved. Then there will be gone focus, and it is the fibrotic nodular lesions in the lungs where this bacteria get colonized. There will be a gone focus. It is the fibrotic nodular lesions in the lungs, and it may eventually will become primary complex or gone complex. It is the gone focus plus regional lymph adenopathy. Together they are known as primary complex or gone focus. This gone focus plus regional lymph adenopathy. This regional lymph adenopathy is the condition in which the macrophages in gone focus spread to the regional lymph nodes, and it may cause the immune response there, and it is known as regional lymph adenopathy. This regional lymph adenopathy and along with gone focus, they are known as gone complex, and later it may develop into Ranke complex. It is the calcification of this primary complex. If the primary complex undergoes calcification, and it is known as Ranke complex. These are the clinical features of this primary pulmonary TB. This gone focus. First, the gone focus will be appearing, the fibrotic nodular lesions in legs, and it will progress into primary complex when it spread into the regional lymph nodes, and the calcification of this cone complex will lead to the formation of Ranke complex. And this primary pulmonary TB is not infectious, and that it will not spread from one person to another, and it occurs mostly in children because they have a low immunity. As the children are having low immunity, they usually occur in children and in immunocompromised people. Then coming to the secondary pulmonary TB or post-pulmonary TB. It is due to the reactivation of latent TB, as we said earlier, the second phase of this primary pulmonary TB. The reactivation of latent TB, if the reactivation of latent TB occurs, it will lead to secondary pulmonary TB. The involved portions are apical and posterior segments of upper lobe is involved. Apical and posterior segments of upper lobe of lungs is involved. Here, Asman focus will be formed there. It is similar to Gone focus, but in the upper lobe only the site will be different. Then it may progress into Simon focus, the lesions in the apex of lungs. Lesions in the apex of lungs. It is common in adult, unlike the primary pulmonary TB, which is common in children. This is common in adults, and it is also infectious. While the primary pulmonary TB, it is not infectious. Then coming to the next type of TB, extrapulmonary TB. In the TB, if the TB occur in other parts of the body other than lungs, it is known as extrapulmonary TB. If the lymph nodes are involved, they are known as tuberculosis lymphadenitis, and if it is in pleura, it is known as pleural TB. And the TB may occur in upper airways, genital tract, skeletal TB may occur, central nervous system, gastrointestinal tract, tuberculosis, pericarditis, which occurs in pericardium, scrophulodema, and lupus vulgaricus, which affects skin, and biliary tuberculosis, which is disseminated TB. These are different kinds of extrapulmonary TB. Coming to the lab diagnosis, the specimen is the sputum. This sputum is decontaminated by Petrov medium, because the sputum may contain other bacteria as well. We have to kill the other bacteria other than Mycobacterium tuberculosis. So it is decontaminated by Petrov medium. Then acid-fast staining is done to find out the bacterium. This Mycobacterium tuberculosis is acid-fast, and it is cultured on Lowenstein-Jensen medium. It is the typical medium used for the culture of Mycobacterium tuberculosis, Lowenstein-Jensen medium. It may take 6 to 8 weeks of incubation, but this is more sensitive test. And to lesser this time of incubation, automated culture methods are also used. And another important process is that gene expert or CBNAT is used. It is sensitive and also less time consuming. Sensitive and less time consuming. Here what happens is that nucleic acid amplification is done, and by doing this test we can simultaneously detect the presence of Mycobacterium tuberculosis, and we can find out the sensitivity of this Mycobacterium to rifampicin. And the diagnosis of latent TB, it is done by Mantoux test. Mantoux test, you might have heard about this Mantoux test. It is the intradermal injection of protein derivatives. The protein derivatives of Mycobacterium tuberculosis is given as intradermal injection. If there is latent, if there is this tuberculosis, Mycobacterium tuberculosis is in the dormant stage in our body, there will be the formation of induration. And we can confirm that we have latent TB. Interferon gamma release assay is also done to diagnose this latent TB. That's all about this Mycobacterium tuberculosis. Thank you for listening.